Okay, now we're recording. That's an excellent question. I was going to bring it up today. We are running behind. Part of that was we did miss at least one class because of my infusion they did on a Thursday. And then there's been other issues either with my health or other things that have probably slowed us down some. So here's where we sat. We're in the very last example in chapter 5. Okay? Now, rather than giving you okay, now I just decided to revisit this. Okay, what we'll do, I will give you today the chapter 5 test. It's going to be fairly short, and I think you can do it pretty easily. Okay, and then we'll have class today and Thursday, and then on Thursday, I'll just give you the final exam. The final exam will have maybe one or two questions from chapter 6, and that's the only testing you'll be having on chapter 6. So we will not have a chapter 6 test, but we'll have tests 1 and 2 cover chapter 4. The test 5 I'll give you today, and then the final exam will have one or two questions on 6. The rest of it will be from the other chapters. Okay, does that kind of answer your question?
And when is the test due, the final?
Okay, now that's another excellent question because there's some depending here. Here's what the deal is with that. Are any of you graduating this term, this fall? Okay, if none of you are graduating this fall, or for all who are not graduating this fall, your final is your test. The final exam is due back in sometime next week. That's pretty nebulous, isn't it? Let's see, this class is starting at 10 o'clock. Technically, it's due on Tuesday. But you know what? I'm not going to push you to that if you can get it to me anytime next week. And when I say that, I mean by 12 o'clock on Friday, 12 o'clock noon on Friday, because I need to have the weekend to grade everything. I've got to get caught up on grading. So, and there's yet another issue. I'll address that in just a second. But the so you have all next week. So if you can, try to get the chapter 5 test that I'm going to give you today done this week if possible. But if you can't get it done this week and need the weekend, that'll be fine too. But I'm going to try to make this test fairly short. Well, I don't know. Actually, it's not all that short, but I think you can do it within a week. The final exam is short. I can't remember now. I think it's just 10 questions, and maybe some of those won't be. And here's James coming in. Let me see if I can get him in, and let me figure out which James this is. I didn't remember having a James. There it is, James Flynn. Okay, that's it. I just didn't used to seeing him as just James. Okay, so I hope that's the James that I just let in with James Flynn. Okay, and now I think we broke double digits. Okay, yes. Okay, now I know that's crowded at the end, but the other option would have been wait till Thursday and include on the chapter 5 test a couple questions from chapter 6 and do the final. Figured this would break it up for you a little bit more. Okay, so how does that sound? Is that doable? Did that answer your question?
Hey, can I catch that? And do we drop the lowest scoring test? Is that
Uh,
what you said?
yes, you get to drop. Okay, your research paper cannot be dropped. The final exam cannot be dropped. But of the 3 chapter tests that we'll have, the 2 on chapter 4 and the 1 on chapter 5, you will be able to drop the lowest test score there. if it helps your average. Now, of course, for those who haven't turned in a research paper and you get a 0 on that, you're going to need every test you can to roll that 0 up. But don't do that. Get your papers in. So that leads to the next thing. It was going to be one of the first things I said. Your research paper is due by Thursday. Now, if we were in class, I would say by class time on Thursday, okay? You have to bring it in by the beginning of class on Thursday. But we're not in class, so I'm going to give you until 11:59 Thursday evening. And here comes Alondra. Let me get Alondra in. Okay. Helping pull up a little bit on the bottom part of the alphabet there. Okay, so you have to. Now, if you can get me the paper sooner, get me the paper sooner. The sooner you can get any of this stuff in, the better. If you haven't turned in test 1 on the first half of chapter 4, please get that in to me as soon as you can. If you haven't turned in test 2, which is the second half of chapter 4, please get that in to me. And then, like I said, I'll be giving you your chapter 5 test sometime later today. And now as I think about it, it is a relatively long test, but it shouldn't take you that long to do. I hope not anyway. So anyway, do the chapter 5 test. Work on that this week as hard as you can. Use the weekend if you need it, but then get your final done. The final is short. I think it's only 10 questions, and actually it may wind up being shorter than 10 questions because we will not have done as much in chapter 6 as what the final will cover. So I'll let you know when I give you the final Thursday at the end of class or sometime. I'll show it to you and say, okay, these questions you do, these are optional. Okay, so it'll be a pretty short test. Okay.
Mr. Fowler?
Yes.
Is the chapter 5 test, is that test 3?
Test 3, yes. I believe that's right, yeah. Okay, good. Any other questions? One other issue, student course evaluations. They were very, very, very late getting these opened. I don't know if you've checked your email lately, but they did come out with an email sometime either right at the end of the week before Thanksgiving or sometime during Thanksgiving week when you probably weren't checking emails. But check your emails. The directions there of how to log on to this and everything are in the email. I can't tell you for certain because I haven't found that email yet. They may have just sent it to students and not to faculty. But Banner was the problem. We've had the evaluation package. We've used it for years, but getting it to communicate with Banner was the issue. Banner just doesn't seem to be a very good, operating system, but it's what we're stuck with. Okay, so please do use student course evaluations. All right. Any other questions, issues, concerns before we get going on trig this morning? Okay, I'm going back to 5.5 and we'll go from current slide. So any questions, any issues, any concerns? No. That's it. That's the last test before the final. We will not have a test on chapter 6 because we will not have covered everything in chapter 6, but we'll get started in chapter 6 today, and you'll find chapter 6 is a pretty easy chapter, I think. So we'll try to get going as much as we can there. All right, any other questions? Good questions, by the way. Great questions. All right, we're in chapter 5, the very last example in chapter 5. Chapter 5 is analytic trigonometry. We're in 5.5, the last section in chapter 5, multiple angle and product to sum formulas, and We're on page 387, an application of this type of problem. Okay? Now, here's example 10, page 387. Ignoring air resistance, the range of a projectile fired at an angle theta with a horizontal and a initial, at an angle theta with the horizontal, and with an initial velocity of v0 feet per second, this is the range. Okay? R, the range. R is equal to 1 over 16 times v0 squared times the sine of theta times the cosine of theta. Okay, now you might think, where in the world did that come from? And you might also think, and this is a legitimate thought, the problem is I've lost my pen. There it is. Okay, my ionizing pen had rolled away. Let me draw a little picture here, and this isn't going to be a very good picture. Here is the horizontal, supposedly. Okay, you're firing the projectile at an angle theta. Okay, the range measures how far this goes before it lands. That's supposed to be a parabola. It's not a very pretty parabola. So this is the range here. This is what they're calling R. Okay, now the initial velocity of this, that's what they're calling v0. Okay, now, and the angle between the horizontal and v0, that is your angle theta. So now you might say, where does the 1/16 come from? That's because we're using US customary measures. 16 is exactly half of 32, which is the acceleration due to gravity in the US customary system. In other words, feet per second squared. Okay, 32 feet per second squared is the acceleration due to gravity. Without going any further than that, that's where the 16 comes from. And then, sure enough, at the bottom they say where r is the horizontal distance in feet. That's what I said, we're measuring this in feet. Okay, that the projectile travels. Okay, so there's your setup. Here's the problem. A football player can kick a football. Now, you might not think of a football being a projectile. It isn't a particularly good projectile, but a football player can kick a football from ground level with an initial velocity of 80 feet per second. Well, what do we call that? We call that our v sub 0, 80 feet per second. It says write the projectile motion model in a simpler form. Well, what is it that makes this not a very simple form? Well, it has both sines and cosines in it, and that makes it hard to solve. But because of our double angle formula, if you remember, the sine of 2 theta is equal to twice the sine of theta times the cosine of theta. Remember that one? So therefore, sine of 2 theta times, sine of theta cosine theta, if you divide both of those by 2, then you could rewrite this as r is equal to, dividing by 2, that makes 1 over 32 v0 squared times the sine of 2 theta. That's a simpler form than this one. So that's the first part of our problem here. Write the projectile motion model in simpler form, and that would be r is equal to 1 over 32 v0 squared times the sine of 2 theta. Okay, now the question is, next question, the B part, at what angle must the player kick the football so that the football travels 200 feet? Okay? Now hold on a moment there. This is a place kicker, 200 feet. Divide 200 by 3, and that would be 3 will go into 26 times, and with 2 left over, and another 6, that's 66 plus yards. Hey, Nick wants to sign this guy up, okay? Because that's a pretty good foot, okay? Pretty good leg on that guy or gal, whoever it is. Okay, so at what angle? So we want to solve this for your sine of 2 theta. So let's do that. Let's first multiply both sides by 32, and that would give you, I'm going to switch sides on it too, V0 squared times the sine of 2 theta is equal to 32R. And divide both sides by V0 squared. V0 squared. That gets rid of that. And that's what we've got. Now, oh, here comes Jared. Okay. Let me get him marked here. Hold on just a minute. I have to undo my stuff here. There, we got it. All right. That gets us up to 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. An even dozen students, is that what we've got? Yes, good deal. Let me just make sure there's nobody else in the waiting room not being counted. Okay. All right. Jared, we're in Chapter 5, Analytic Trigonometry, the very last section, 5.5, Multiple Angle and Product to Sum Formulas. And we're on the very last example. It's the application problem. They're in the wrong sport. They're in football rather than baseball, but I guess we'll have to live with it. And this is a projectile motion problem. Oh, and here comes Courtney. Oops, 2 people are waiting. Courtney and James' iPhone. So I think James was already here before, and Courtney's here now, and I already had James here. Okay, so hopefully he's back in again. Now that should give us 14. Oops, we just dropped one. I bet you that was James again. Okay, so now we only have 13 students in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Well, that has it right. I don't know. I hope I've not failed to mark somebody present. Not that it matters much at this time of the term. But anyway, at what angle must the player kick the football so that it travels 200 feet? Rather than do an inverse sine here, I'm going to leave it in terms of sine of 2 theta. So let's plug in what we know the things to be. This will be 32 times, now what is this 200 feet? That now is the range. That's the R. So this will be times 200 feet. I'll leave off the units for now. Yeah, let's leave them off. Divided by, okay, yeah, I'll leave them off for sure. The velocity was 80 feet per second. We're going to square that. That's 6,400 squared. Is 80 times 80, 6,400. All right, so what does this give us? 2 times 32 is 6,400. And this is over 6,400. Now, isn't this working out well? That's going to be 1. So the sine of 2 theta, is this? Yep, that's it. The sine of 2 theta, if I could get my pen to come back, it was just with me. There it is. Nope. Where did it go? There it is. Okay. Sine of 2 theta is equal to 1. Well, where is the sine of theta equal to 1? That would have to be, sine of 2 theta would have to be, now, using US customary, wouldn't that have to be 90 degrees? Believe it would. That's the only place where sine is 1, is that pi halves are 90 degrees. So that means theta would have to be 45 degrees. Okay. And that would be the maximum distance he could kick the ball. 66 yards? Okay, sign him up. Okay. If he can kick it accurately 66 yards, we've got us a winner. Okay. Of course, the goalposts sit back 10 yards from there, but that's still a mighty good leg. And that would be a range. That's where it hits the ground. It would have to go through the goalpost. So it's maybe not quite as good as what it sounds like. Any questions on this? Do you see how that worked? Now, what I'm going to do is see how they solved the problem. Okay, A, you can use the double angle formula to rewrite the projectile motion problem as, and what they did, they multiplied by 2 here and divided by 2 there. Okay, that was sort of sneaky, but it worked. Okay, we got the same thing that they did. Okay, because that becomes 1 over 32 v naught squared times the sine of 2 theta, because the sine of 2 theta is 2 times the sine theta cosine theta. Okay, that's what we got. So there is the simplified model. Rather than having a sine and a cosine, you're now down just to a sine. Of course, it's a double angle, but that's okay. We can live with that. Okay, the B part then says, take this new model here, which they had here and they rewrote here, fantastic, and we want to solve this for at least the sine of 2 theta. And what, well, no, they plugged in the numbers first. 200 was the range, 1 over 32 was in the problem, 80 squared was in the problem, and sine of, that's your initial velocity, and sine of 2 theta is what we're looking for. And when we do that stuff, then we get 200 is equal to 200 sine 2 theta, okay, because 80 squared is 6,400, 32 will go into 64 2 times with the 2 zeros, 200. So that gives you that, and that gives you sine of 2 theta is equal to 1. The only place where that happens is at 90 degrees, so you know, or pi, I thought for sure they'd go to degrees, but they're leaving it in 2 pi's, pi halves in pi terms, in radians. So dividing the result by 2 gives you theta equal pi fourths. And now they say because pi fourths is 45 degrees, the player must kick the football at an angle of 45 degrees, so the football will travel 200 feet, which is still a mighty good kick. Of course, it comes from that 80 feet per second initial velocity. That's pretty good speed on it. Okay. And that is the last slide. There is a checkpoint like every exercise has or example has. Please do the checkpoint. Any questions on 5.5 or anything in chapter 5? Okay. Now, there are some vocabulary questions. Let's hit those real quickly here if we can. I don't do very much quickly, but let's see if we can. The first one is this one right here. What is sine of 2 theta? That was on the previous slide. Sine of 2 theta is, anyone recall? Two times the sine of theta times the cosine. That's number one. Number two, what is cosine 2 theta? Now, it actually has 3 different answers you can write down. Give me one of those 3 answers. To me, the easiest one to remember is this one. Cosine squared theta minus sine squared theta. The other 2 are, and I always have to go back and look because I don't want to get the sign wrong or the things out of order. The other 2 are, it's the same as 2 cosine squared theta minus 1, and the other one is 1 minus 2 sine squared theta. So those are 3 possible answers for cosine 2 theta. Now, backing up and doing a different one, what in the world is sine u cosine v? Now that you don't have to turn as far back, but that's your product to sum formula. Okay, so that's on page 385. Sine u cosine v is the 3rd one listed there, and this is not something I ever memorize. I always look it up. 1/2, I do not trust my memory that well. 1/2 of, because look how sort of bizarre this is, the sine of the sum of the 2, u plus v, plus the sine of the difference of those 2, u minus v. Okay, that's your product to sum formula. Okay, number 4. Where can I write number 4? Let me write it here. What is 1 minus cosine 2u over 1 plus cosine 2u? Now, just hazarding a real quick guess, to me that's obviously a tangent, and if you go back to your half angle, no, your power reduction formula, that's the tangent squared u. Okay, and from that you can get your half angle formula. Okay, so that's number 4. Number 5, let's see if we can fit it in here. What is sine of u over 2? That is your half angle formula. Okay, so flip back a few pages there. It's going to be right after the one we did. Oh, there it is on page 384. Sine of u over 2 is equal to either plus or minus, depending on where, in which quadrant this is located. This is such a pain in the neck. Okay, the square root of 1 minus cosine u over 2. Okay, that's your half angle formula for sine. And number 6 is the what they call the sum or difference to product formula. So this is cosine u minus cosine v. And this again is one I always look up. I never trust my memory on. And here's why. That's the last one listed on the bottom of page 385. And this is going to be a pain in the neck to write in the little space I've got. Negative 2 times the sine of the sum of those two, u plus v over 2, the average of those two, times the sine of the half the difference of those two, u minus v over 2. Never do I try to memorize that. I look them up if I need them. Okay, so there's your vocabulary. All right, here's the homework exercises. Do any of the odds 7 through 13. They're all at Calc Chat. 9's at Calc View. 15 to 19, all at Calc Chat. 21 to or 23, both at Calc Chat. 21's at Calc View. 20.
Page are we on?
This is on page 388. It will continue on 389. Okay. So I said 21 or 23, both at Calc Chat. 21's at Calc View. 25's at Calc Chat. Any of the odds 27 to 33, they're all at Calc Chat. 27's at Calc View. Any of the odds 35 to 39, they're all at Calc Chat. 37's at Calc View. Either 41 or 43, they're both at Calc Chat. 41's at Calc View. 45 or 47, they're both at Calc Chat. 45's at Calc View. 49 or 51, they're both at Calc Chat. 49's at Calc View. 53 or 55, they're both at Calc Chat. 53's at Calc View. 57 or 59, both at Calc Chat. 61 or 63, both at Calc Chat with 63 at Calc View. Any of the odds 65 to 69, they're all at Calc Chat. 65's at Calc View. 71 through or 73, both at Calc Chat. And you can explore doing 75. It should be at Calc Chat. It's a true false. Should be at Calc Chat, and 77 should be at Calc Chat. Now that finishes Chapter 5. Any questions either on 5.5 or in Chapter 5 in general? Okay, and like I said, I'll try to get the test out there. I have a couple of hours at lunch between 1 and 3. I'll try to get it out during that 2-hour period. No promises. Yes.
I thought you sent Chapter 5 test out already.
Did I? Maybe I did. Okay. I remember. Okay, I remember I asked y'all if you wanted to. I couldn't remember what your answers were. So fantastic. Chapter 5's already there. You've been working on it. You're almost ready to turn it in. That's good news to hear. Okay, good news. So Chapter 5's already there. We just finished the last problem. Whew. All right, good. The old gray cells ain't what they used to be. I have a great memory. It's just really short. Okay.
Mr. Fowler,
Yes.
what week are we in? Like, what week is this?
We're in week 15. Okay. And since you asked that, I'm going to rub this in a little bit. Maybe it may not make any difference to you at all. This happens to be my last full week of teaching. Okay. Because we have classes this week, and I do have one class next week, the second mini-term course. We do meet on Tuesday of next week and have class, and their final is Thursday. But the rest of my classes, all will be doing your finals for next week. So this is my last full week of teaching, because in January I'll just be doing administrative stuff. The month of January I'll be retiring the first day in February. So this is it, folks, for you partially, but for me almost, not totally, but you know, it's there. All right, just that's beside the point. All right, if you want to look at the chapter summary, it has a whole lot of really useful information in it. Split into sections gives you most of the identities and formulas and other things that you use. On page 390, you have sections 5.1, 5.2, and 5.3. On page 391, you have sections 5.4 and 5.5. It really is a concise, useful set of organization. If you feel like you need a few more exercises to work on, then now none of these are at Calc View, all of them are at Calc Chat, but the odd numbered under 5.1, either 1 or 3, both at Calc Chat. 5's at Calc Chat. Any of the odds 7 through 15 are at Calc Chat, and 17's at Calc Chat. For 5.2, any of the odds 19 to 25 are all at Calc Chat. 5.3, 27 to 39 or 31 are at Calc Chat. 33 to 41 are at Calc Chat, and 43 to 45 and 45 are at Calc Chat. 5.4, 47 and 49 are at Calc Chat. 51's at Calc Chat. 53 or 55's at Calc Chat. 57 or 59's at Calc Chat, and 61 or 61's at Calc Chat. 5.5, the one we just finished, 63's at Calc Chat, 65's at Calc Chat, 67's at Calc Chat, 69's at Calc Chat. Either 71 or 73's at Calc Chat. 75's at Calc Chat, 77's at Calc Chat, 79 is at Calc Chat, and then either 81 or 83 are at Calc Chat. Then there's a chapter test on page 394. Now this has all the answers in the back of the book, not just the odds, but still at Calc Chat it's only the odd number exercises. So either 1 or 3 are at Calc Chat. Any of the odds 5 through 9 are at Calc Chat. 11's at Calc Chat. Either 13 or 15's at Calc Chat. And any of the odds 17 through 21 are at Calc Chat. Now, if you really want a challenge, the proof of the sum and difference formulas, some of those are given on page 395, which is really a pretty big pain in the neck, but you may find it interesting to do. And there are more proofs given on 396. And then there's a problem solving section on 397 and 398 if you want to look at that. You don't have to, it's not required, you're not tested on it. But let's move on to chapter 6, additional topics in trigonometry, and these are some very useful topics. So I'm going to get out of chapter 5 and close chapter 5 and open chapter 6, 6.1. Okay, and this means that all my toolbars have moved back in the way again, so let me get them out of the way. All right, and we'll go from current slide 6.1. Okay, chapter 6 is additional topics in trigonometry, and 6.1 is the law of sines, page 400. Okay. Our objectives here are to use the law of sines to solve some oblique triangles. Now, what do we mean by an oblique triangle? That's any triangle that is not a right triangle. That's what an oblique triangle is. Okay? Now, there's several classifications of these. Now, what the capital A stands for are angles, and what the capital S stands for is length of a side. So the capital A stands for the measure of an angle, and the capital S stands for the length of a side. So the law of sines is used anytime that you have two angles and one side. So that could be an angle, angle, side. You know this angle, and you know the side in between those two angles. Okay? That's angle, angle, side. I'm sorry. Angle, angle, side. You know this angle, and one of the two sides opposite those angles. That's angle, angle, side. Angle, side, angle. You know this angle, and the side in between. That's angle, side, angle. We also use the law of sines to solve oblique triangles when you know, in this special case, side, side, angle. Okay? And we never spell it the other way. Okay, never. Okay, it's always SSA. Okay. Now, we'll find the areas of oblique triangles. Okay, and that's going to be pretty fun and a fairly easy thing to do. And we'll use this law of sines to model and solve some real life problems. Okay, so here's the introduction. In this section and in the next section, you'll be solving oblique triangles. That's triangles that have no right angles. All three angles are oblique angles, are not right triangles or right angles. As standard notation, the angles of the triangle are labeled capital A, capital B, and capital C in no particular order. Okay? Remember, in right triangles, you always have C being the right angle, the largest angle. Now, a lot of times I will still try to do that, have C being the largest angle just to remind myself it's the largest. In this one, A looks like it's the largest angle, so that doesn't matter. Now, once you have those angles in place, then the sides opposite them are little a opposite angle A, little b opposite angle capital B, and little c is the length of the side opposite capital C, angle capital C. So to solve an oblique triangle, we need to know the measure of at least one side. We got to know one side and any other two measures of the triangle, either the other two sides, two angles, or one angle and one side. Okay, so what we need is three pieces of information. One of them has to be the length of a side. The other two could be one angle, one side, two angles, or two sides. One of them has to be a side. Okay, now obviously we didn't hit all those with law of sines. The next section is going to hit the law of cosines, which covers the last two possibilities. So this breaks down into four cases. Two angles in any side. Law of sines, right there. You know it. We'll see why in a minute. That's angle, angle, side, or angle, side, angle. Either one. Now, what if you have two sides and an angle opposite one of them? Side, side angle. Law of sines is your deal for that one as well. And we always spell it SSA, never the other way. Okay. Now, three sides, no way you can use the law of sines. That's going to be the law of cosines, 6.2. Two sides and the included angle, no way you could use the law of sines. That's got to be the law of cosines as well. Okay, so these two cases we'll do in 6.2. These two cases here, or I actually look at this as three cases, will be the law of sines. Okay, so here's what the law of sines is. If ABC is a triangle, usually an oblique triangle with sides A, B, and C, side little a is always opposite angle capital A, side little b is always opposite the angle capital B, and side little c is always opposite the angle capital C, then here's what your law of sines is. The side opposite an angle, the length of the side over the sine of its angle, that angle is opposite, is equal to the length of one of the other sides over the sine of its angle, and that's also equal to the length of the third side over the sine of the third angle. It always works. Okay, pretty simple formula. Now here is an illustration of that, and it helps you see kind of how that works. If this is an oblique triangle, no right angle in it. Looks like to me A is the largest angle there. It doesn't matter, but it's no right angle in it. Well, drop the perpendicular from angle C down to the horizontal side AB, okay? And what you have then, you've just created a right angle here because that was perpendicular, the vertical here perpendicular to the horizontal there. Now, from this, you see that the angle A, okay, the ratio of, okay, the sine of angle A is its opposite side, H, over its hypotenuse, B. So sine of capital A, let me write this down for you, is equal to H over B. Okay? Does everybody agree with that? This is the opposite side, because there's a right angle here. Okay? Opposite side over hypotenuse. Now, if you go over here and do the sine of angle B, that's equal to the opposite side, its H, same H, over little a, because that's its hypotenuse, because there's its right angle. Well, because those H's are exactly the same, this says that B sine A is equal to H, and this says that A sine B is equal to H. Well, guess what? Those are the same H's, so this says that B sine A is equal to A sine B. Well, let's divide this side by B, both sides by B, and both sides by A. Here the B's go out, here the A's go out, and there you have, now I've got it upside down, but it's still true. Sine A over A is equal to sine B over B. Just flip these over and they're the same. Now if we had dropped the perpendicular this way, okay, and made that our 90 degrees, you could have had the same relationship between B and C. So that all three are going to be the same. Now this is pretty obvious for an acute angle. If A is obtuse, which is also an oblique triangle, no 90 degrees here for sure, okay, then the sine of A, this A, is the same as the sine of that A, because, well, wait a minute, let me make sure I'm saying that right. Yeah, the sine of this angle is the sine of its reference angle in this quadrant, the angle from the horizontal to that line. So these two sines are the same. So again, it's H over B, and the sine of B is H over A. So everything works out just the same. Okay, and if you had initially dropped that perpendicular there, then the sine of C would be this new H over B. Whoa, where is that? Okay, and the sine of this B would be this new H over C, and they all work out the same. Now, the law of sines, as I said before, can be written in the reciprocal form. You can put the sines on top and the lengths on the bottom, or you can put the lengths on top and the signs on the bottom. Either way you want to, the ratios are the same. Now, you might say, well, what about dividing by 0? A sign could be 0. Well, the only place where sign is 0 is when capital A is equal to 0. That's not going to form a triangle, okay? Or capital A is equal to, or B or C, either one, is equal to pi. Well, again, you're not going to get a triangle out of that because you're flat. You're on a flat line there, okay? So you'll never have a sign being 0, and you'll never have your lengths being 0 unless there's no angle there, okay? So this always works. Now, let's pay attention to what we've got here. In order to use the law of signs, you've got to have at least one side. Where is my pen? There it is. You need to know at least one side and its opposite angle. Either A and A, B and B, or C and C. If you know at least one of those, you're made. Law of sign works. Okay? If you know that, it works. So let's do example 1 here. For here is a triangle given in this figure. Capital C, they made the big angle here, 102 degrees. Capital B looks like the small angle here, that's 29 degrees. And this length over here is 28 feet. Okay? Well, guess what? You have a side with its opposite angle. You know them both. You can solve this. Remember, you need 3 pieces of information. We got them. 2 angles and a side. If you have that, you can solve the thing. You've got to have at least one side and then any other 2 pieces of information. So law of signs works here. And I like to start with this right here. So going B over sine B is equal to little c that we don't know over sine C that we do know. Plug in the numbers. 28 over sine of 29 degrees, be sure you indicate what unit you're measuring is equal to little c, which we don't know, over the sine of 102 degrees. Okay, now what I like to do is isolate the thing we're looking for. And that's going to be, this is called a proportion here. Set 2 ratios equal to each other. The proportion will be C times the sine of 29 is equal to the product of these two. So that would be 28 times the sine of 102 divided by the sine of 29. Okay. Now, when you're doing these, be sure, be absolutely certain you're in the right mode. And the right mode here, I've missed some phone calls this morning. I don't recognize any of the area codes. No, that was yesterday. I think those were from Puerto Rico or somewhere, so I don't know who was calling me from Puerto Rico. Okay. All right. Now, in order to do sines and cosines, if you're using your phone, turn it sideways. That gives you a scientific calculator, and you have the sines and cosines here. Now, what you need to do is check your mode. We're in degree mode. This calculator's in radian mode. I don't know if you can see that, RAD. Down here, you see a DEG. When you press that, the RAD disappears, and now you're in degree mode. If you don't see, this is on an iPhone. I don't know how your phones do or your calculators do, but be sure you get in the right mode. Okay, so what we have here is 28 times the sine of 102. Now on my phone, this is an iPhone, I have to enter the argument first, the degrees first. 102, then I press the sign button, that's over here, okay, and it didn't do anything. There we go. And divide that by the sine of 29. Again, I have to hit 29 first and then press the sine button and then hit equal, and what do we get as an answer? Something just over 56 degrees. I mean 56 feet. Okay, got to get my pen. So C is approximately equal to 56 feet. Now, your book is going to put a bunch of decimals after it. If you don't have any decimals here, I see no justification for putting decimals there. Okay, 2 significant digits here. How can you get more than 2 significant digits there? Now the question you ask yourself, is this a reasonable answer? And here's something to gauge that by. As I said before, this appears to be, B appears to be the smallest angle. You would expect it to have the smallest side opposite it. This 102 is obviously the biggest angle. You expect to have the longest side opposite it. So 56 is considerably longer to, it happens to be exactly twice the value of B. That won't always be the case, but at least it's the right relative size. Okay, what do we do from here? Are we stuck? We've still got one angle and one side we don't know anything about. What do you think? Are we stuck? Guess what, team? Anytime you know 2 angles of a triangle, you know the third angle. Because 102 plus 29 would be 131, and the 3 angles of a triangle always add to 180. So that's the next easiest thing to do. This gives you what, 49 degrees? Yeah, 49 degrees. So sure enough, you do know this angle, 49 degrees. And now we can do the law of sines again. I would always stick with the angles that they gave you, angle and side ratio they gave you. So 28 over sine of 29 degrees is going to be equal to A, the side we don't know, over the sine of 49 degrees. Okay, and again, that would produce A equal to the product you know, 28 times the sine of 49 degrees. Now the book does it a slightly different way, and if you like the way the book does it, go for it, over the sine of 29 degrees. I'm getting chilly in here, I don't know. Don't know why, sorry about that. Let's see how much time we have. Only got, I think I can make 12 minutes trying to stay warm here. Okay, so let's pull our calculator and go again. 28 times the sine of 49, so I have to enter 49 and then do a sine button and divide that by, and I have to enter 29 and hit the sine key and do equal, and I get the A is approximately equal to 44 degrees. I mean 44 feet. Now let's see if that even makes sense. Okay, well, the biggest, where in the world is my pen now? It was right there. There it is. Okay, the biggest angle opposite the longest side, that fits. the smallest angle opposite the smallest side, that seems to fit, and the middle angle is opposite the middle side, 44 feet, that seems to fit. Now that doesn't guarantee you got the right answers, but at least it tells you you're in the right ballpark. Now, I can almost guarantee you that the book is going to want to carry a lot more decimals than what we did. So let's see what they did. Well, we'll just see what they, let me just see it now. I did 56, they did 56.49. I did 44, they did 43.59. No reason, there's no justification for that. And the other angle is 49 degrees. Got it. Okay. So let's see how they did it. The third angle, they start that way, which is not bad, is always 180 minus the sum of the two you know. And that would be 180 minus 29 minus 102, and that gave you 49 degrees. Okay? Now, by the law of sines, then the ratio of the side to the sine of its opposite angle of each of those angles are all equal. That sets up ratios equal to each other. It's called a proportion. You solve a proportion. Now, they do it this way, which is basically the same way we did, but they don't explain why. Okay, and it just kind of irritates me that they don't. Using b equal 28. Well, actually, what they do, remember, it was a over sine A is equal to b over sine B. They just multiplied by sine A to give you A, which you're looking for. Now, they're starting off with the angle you calculated. I like to start with the ones you know. You know this one, but they gave you this the other angle, C, as well. That's why I wanted to start with C. But they're doing the one you calculated. You may be launching with an error here if you made a mistake in your subtraction. But when you do that, you get 28 over times the sine of 49, which is the second thing we did, divided by sine of 29, and that gives you about 44 feet. No justification for having two decimal places there. And then, similarly, C is sine B over B times the sine of C, which if you like doing it that way, it's perfectly fine. I like doing cross multiplying and saying B times sine C divided by sine B. It works the same, and that gives you 28 over sine 29, same as you had here. That's the ratio you know. That was the one that was given. And then multiply this by the sine of 102, and that gives you 56, approximately 56 feet. Any questions? Oh, goodness. Now, like I said, I only got a few minutes left, but between the sneezing and my still am somewhat anemic, I'm need a little bit of a boost here, so I'm going to drink me a little swig of Coke I had left over from yesterday. Okay. Sorry about this. My head's clogging up and everything. So that was example 1. They don't do in the slide set example 2. And I think we've got time to do it if we do it quickly. So I don't do very many things quickly, so let's see if we can get this done as quickly as possible. And this, I can't believe this, that moved this down here after I'd already gotten it squared away. But it left my whiteboard alone, so I think we can go with that. Example 2. A pole tilts toward the sun, that's a key here, at an 8-degree angle. Now this is a power, well, let me get my, I'm trying to write on my book. Okay. So here is your horizontal. Okay. Here is your pole tilting 8 degrees toward the sun from the perpendicular. So this is 8 degrees. and this is supposed to be 90. I'm obviously not quite there. Okay, from vertical. It casts a 22-foot shadow. So the shadow here goes out to here somewhere. Here is the shadow of that pole. Okay, and this is 22 feet. Okay. The angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. This is 43 degrees. You're standing on the ground. From the horizontal to the top of the pole is 43 degrees. The question is, what's the top height of the pole? What is your, let's call it P. I know they're not going to call it P in the book, but what's the height of the pole? Okay, well, to start with, this angle here, this is 90, that's 8, so this angle has to be 98 degrees. So sure enough, we have two angles. We have one side, you got to have one side, and two angles. Anytime you have two angles and a side, you can use the law of sines. But you might argue and say, wait a minute, this is the side opposite this angle here, which we don't know. You've got to have a ratio of a side to the angle, the sine of the angle. Well, guess what? If you know these two angles, you know that one. Okay, because this angle here has to be the sum of these two, which is 141, the difference of that, and 180. And that gives you 39 degrees. So you do know that angle, 39 degrees. Well, now we know a ratio. 22 feet is to the sine of 39 degrees as, now guess what? We're not interested in this side. We want to know this one. So the only one we're interested in is this one. P divided by 43 degrees. Now they want to call it the same angle as that one, so I'm going to call it P, height of the pole over the sine of 43 degrees. Okay, and then P is equal to the product, you know, 22 times the sine of 43 degrees divided by the other side that you did, the thing that you multiply by the P, which is sine of 39 degrees. Okay, let's pull out the whole handy dandy calculator here. We got 3 minutes. I think we can get the calculations made in 3 minutes. Okay, turn it sideways to get you into scientific mode. Clear that last one out, and we have 22 times, and on this calculator I have to enter the, make sure you're in degree mode. I am. Okay, 43 degrees, take the sine of that and divide that by 39 degrees, taking the sine of that, and hit equal, and I get that the pole is about 24 feet out of the ground. So P is approximately 24 feet out of the ground. Now I'm sure the book is going to do 23.84, something weird like that. Now the pole itself is taller because obviously it's in the ground a certain distance. Who knows how deep? Usually power poles and things like this, they try to plant at least, I think, 6 feet deep. Some of you, if you've ever worked with that, you may know better than that, but I've always figured that they try to get it 4 to 6 feet deep. All right, let's see how the book did. 23.84 feet, which is basically what we got, except I rounded it to 24 feet. Any questions on that? And as in example 1 and example 2, there's always a checkpoint. Okay, so always check your checkpoint. All right. Any questions? All right. So, I don't think we have time to do the ambiguous case, okay, because it takes a while to do, but I'll bring it up here just so that's hopefully my slide will go back to that next time. All right, we'll pick up with the ambiguous case, and this is always, to be ambiguous, you don't know. Well, no, we'll get into it next time. All right. Let me plug my phone back in, and then I'll make my assignments. Okay. Right. I was just going to say, I know that's happening. And we're starting, I've already got a mark there. So homework exercises here. Basically, folks, we made pretty good progress, so we will be able to hopefully next time get into the law of cosines. But do any of the odds 5 through 21. They're all at Calc Chat, 11's at Calc View. Okay? I think you can do any of the odds. The only thing they do say, if possible. So you may have an ambiguous case here. Try to do some of the odds 23 through 31. They're all at Calc Chat, 29's at Calc View. We'll definitely pick up the rest of those next time. All right. Any other questions before we get out of this one? Okay. Now, my question to you, Azora, right? Is this something that you wanted private, or does it matter if other people are listening? Private. Okay. So I hate to do this, folks, but could you please log out? Okay. I see some people are already going, so please go on and check out, and I'll just stay on for Azora. Does anyone else have a question you don't mind asking in front of others?
Can I ask one tiny question?
Yeah, surely.
So when do you want chapter 5 test?
As soon as you can get it to me.
Perfect.
I'd prefer it by Thursday, but if you can't get it done, because I'm only you had it over Thanksgiving. If you can get it to me today, tomorrow, or Thursday, that would be ideal. If you can't, get it to me as soon as you can.
All right, thank you.
All right. The reason I say it that way is I'd rather you not have the final and that at the same time. Okay. Just for so you don't have as much pressure on you. That's all. Okay. Keep going, folks. Okay. We'll see you on Thursday. All right. Good deal. They're going. Jermisha, Alondra, Jared, Bennett, and James. That's sort of suspicious there. Is Jared, Bennett, and James all the 3 baseball players? And they're all still in here? I'm wondering if they just left their thing open and they're doing something else. No, at least James went out. Jermisha's still here, Jared and Bennett. Can I get y'all to log out, please? To leave the meeting. I don't know if I can kick you out or not. Let me see if I can. I can ask you to unmute. Is there anything else I can do? I don't think I can. Okay. Folks, Jermisha, Jared, Bennett, can you please leave the meeting? If you have a question, ask it. Okay, Jared left. We've still got Jermisha and Bennett here. Don't know if they're near the phones or not. Okay, Jermisha, Bennett, can you please leave the meeting? Azora has a question she didn't want to ask in front of everybody. Jermisha and Bennett. Okay. Azora, I have a suspicion that they're not even near their phones or devices or whatever. Do you want to risk it, or would you rather them get out first?
I can go ask a question.
Okay. What is it?
So I know I'm behind in a lot of work. I know I am. I've been having a lot going on
Uh-huh.
for me trying to work and all that stuff and family stuff. I was trying to see, is it too late for me to turn any of my work in?
No, you can turn anything in anytime. Please get it to me as soon as possible. And by
Okay, because I know I have to do those tests. I know I've been lacking on my tests and stuff.
okay.
I know how to do the first 2 tests still.
Right.
I will try to get them into you by the end of next week. And I have no clue, when do this class end?
This week we have class today and we have class on Thursday. Those are the last 2 days of class. Now we have final exams next week, so anything you can get to me this week would be great. Thursday, at the end of class on Thursday, I'll be giving you your final exam, and that will be due sometime the following week. Technically, I think it's due on Tuesday, but I'll give you till Thursday. I'll even give you till noon on Friday. But try to get it into me sometime next week, because grades are due in either Monday or Tuesday of the following week by noon that day. So if I don't have things coming in, next week, I can't possibly get everything graded within the deadline. So
Okay, for that paper, it's 1 page, right? That paper.
well, 1 to 2 pages of text. Okay? Yeah, it's going to be on at least 2 pieces of paper, because wherever you start typing on the first page, you got to come down that far on the second page to cover 1 page of text. So try to keep it, between 1 and 2 pages of text. Okay. All right.
Thank you. That's all.
All right. Glad to. All right. Have a good couple days. We'll see you on Thursday.
I will.
All right. Bye-bye.